Hi, welcome to this video. In today's video, I'm going to look at a very interesting series. I'm going to do the Taylor expansion of arctangent x. Okay, I'm not going to use the Taylor expression formula because there is no connection between terms. Okay, so I'm going through the geometry series as a convergent series. Then we pass to and then we use this series as a tool, and then we pass to the Taylor series, okay, as expansion. So now, if I'm doing the first derivative function of this one, so I will have f prime of x, which is 1 over 1 plus x squared, okay? This one, in the same time, arctangent x equal to integral of dt over 1 plus t squared. So as you know, 1 over 1 plus t squared equal 1 over 1 minus t squared. Okay? As you see here, this is written on the form of geometry series as a convergence series. So 1 over 1 plus t squared is given as 1 over 1 minus t squared minus 1 to the n t to the n. Okay? As n goes from 0 to plus infinity as a convergence series, because this one must, absolute value of t must to be strictly inferior than 1. Okay, I'm going to integrate this one, so I will have dt over 1 plus t squared as t goes from 0 to x equal to this integral of this one, so from 0 to x integral minus 1 to the n t to the n, okay, dx. So this one, I'm going to take this sum outside of integral because this series is a convergent series, okay? So it's giving me the sum. I'm taking minus 1 to the n as well because it depends on n. So as n goes from 0 to plus infinity, the integral of t to the n dt as x goes from 0 to x, okay, as t goes from 0 to x. So now we know arctangent x equal to this one, okay, this integral dt over 1 plus t squared as x goes from 0 to x, as t goes from 0 to x, this one equal to this one, this sum. So this integral equal to this sum as n goes from 0 to plus infinity minus 1 to the n. I'm going to look for the primitive of t to the n, which is 1 over 2 to the n, 1 over 2n plus 1 t to the n plus 1, the bound from 0 to x, okay? So this one now arctangent x equal to this sum minus 1 to the n as n goes from 0 to plus infinity, okay? This one is giving us x to the n plus 1 over 2n plus 1, okay? Because 0 minus 0, okay, which is 0. So this is the expansion, this is the Taylor expansion of arctangent x. In this case, for all x, okay, I'm going to do the case when we have absolute value x is strictly inferior than 1, absolute value of x is inferior or equal to 1, and and x is strictly inferior than minus 1, and x is inferior or equal to minus 1, okay? So for this one, absolute value x must be is inferior or equal to 1 in order to have this series convergent, because if absolute value of x is inferior or equal to 1, this series is be convergent. We're going to show that for now. This series convergent, we have to have absolute value of x is inferior or equal to 1, okay? Let's do the cases now. Now I'm going to do the I'm going to show this one is convergent when we have x, absolute value of x is inferior or equal to 1, okay? So as you see, well, I'm going to use the Russian test, okay? So the Russian test. So the Russian test of the limit, let's set a sub n equal to x to the n plus 1, okay? Over 2n plus 1, okay? So I'm going to calculate the limit of absolute value. This is the Russian test, the limit of a sub n plus 1 over a sub n, absolute value as n goes from plus, as n goes to infinity, okay? So I'm going to do the limit a sub n plus 1, which is absolute value of the limit of x, absolute value of x, 2 to the n plus 1 plus 1 2n plus 1 plus 1, okay? So I'm going to simplify this one. I'm going to calculate this ratio, okay? So this one, I'm going to simplify this one. So we'll have absolute value of x, 2n plus 3, x to the 2 to the n, 2 to 2n plus 3 over 2n plus 3, okay, is multiplied by 2n plus 1 over x, absolute value of x 2 to the n plus 1, okay? So what I'm going to do now, I'm going to simplify this one. So I will have absolute value of x to the n plus 1 is multiplied by absolute value of x, absolute value of x squared over this one, which is absolute value of 2n. So I'm going to simplify x to the n plus 1. So I will have what's left, the limit of this one, which is capital A, let's call it capital A, okay, equal to this one, absolute value of x squared is multiplied by the limit of 2n plus 1 over 2n plus 3 as n goes to infinity. The limit of, I'm going to divide numerator and denominator by n. So I will have the limit of capital A as n goes to infinity. So we will have x squared, absolute value of x squared is multiplied by limit of 2 plus 1 over n over 2 plus 3 over n as n goes to infinity, okay? As n goes to infinity. So as you see here, 1 over n is going to 0, 3 over n is going to 0, so we'll have 1. The 1 multiplied by x squared, absolute value of 1 is multiplied by absolute value of x squared. Thus, the limit of this ratio of this absolute value of a n plus 1 over a absolute value of a sub n plus 1 over a sub n as n goes to infinity is giving us absolute value of x squared, okay? So the absolute value of x is inferior or equal to 1. That means it implies this series as n goes from 0 to plus infinity is converge. This series as n goes from 0 to plus infinity diverge to the n plus 1 over 2n plus 1 is diverge, okay? So what I'm going to, so in order to have this one converge, okay, I'm going to make some change in converge if x is inferior or equal to 1, okay? So if absolute value of x greater than 1, okay? Also, We know this formula, arctangent of x plus arctangent 1 over x equal to pi over 2. Okay? So we have this formula. So this one, we have arctangent of x equal to pi over 2 minus arctangent of 1 over x. Okay? Since we have absolute value of x is strictly superior, absolute value of x is to 1, this implies 1 over x, it implies 1 over x is inferior than 1. Between 0 is 1 over x is between 0 and 1. Okay? If I'm replacing 1 over x into x, I will have this series will be convergent. Okay? So arctangent of x equal to pi over 2 minus, I'm going to replace 1 over x into this series. Okay? So we'll have minus this sum of minus 1 to the n. If I'm replacing this by 1 over x, I will have 1 over 2n plus 1 x 2n plus 1. Okay? As n goes from 0 to plus infinity. We are using this technique. Well, now we get this sum. If we have absolute value, the first case, when we have absolute value of x is inferior or equal to 1, we have this expression arctangent of x equal to this sum. And also we did absolute value of x is inferior or is it superior, absolute value of x is superior or equal to 1. We found this sum. Okay? Now I'm going to do the third case, when we have x is inferior or equal to minus 1. Okay? So arctangent of minus x equal to minus arctangent of x, because arctangent x is an odd function. Okay? So that's mean, in the other word, arctangent of x equal to minus arctangent of minus x. What I'm going to do now, I'm going to plug minus x into this equation. Okay? So we'll have minus pi over 2. With this minus become plus, but I'm not going to do the plus because I'm pushing minus sign inside inside of this sum to do, in order to do the minus 1 to the n plus 1. Okay? Minus 1 to the n plus 1. Okay? As n goes from 0 to plus infinity. 1 multiplied by 1 is multiplied by 1 over 2n plus 1. I have minus x to minus x. I have minus x 2 to the n plus 1. Okay? So what I'm going to do now, I'm going to bring this minus side outside. Okay? With this minus, I'm going to cancel out n plus 1 and put it. I'm going to put minus 1, instead to put minus 1 to the n plus 1, I'm putting minus 1 to the n, with taking this minus sign off from denominator. Okay? So we'll have arctangent x equal to minus pi over 2, with this minus sign, minus 1 to the n, as n goes from 0 to plus infinity, 1 over 2n plus 1 x to the n plus 1. Finally we have these three equations. This is for x is inferior or equal to minus 1. Okay? So I have done with this problem. Thank you for watching. I will see you in next video. Bye.